So many times we say that multiplication is gluing. Here we are seeing that several triangles are there where there are common edges and common edges are glued together. We can suppose these as the triangular frames of steel or welded one after another as per the rules of Sanjoy Nath geometrifying trigonometry. And in 3D, we can get the steel frames like truss or the 3D structures which are nothing but the multiplication of trigonometry ratios in a certain way, one after another, because the multiplication in geometrifying trigonometry is not commutative. So the order of multiplication is very important, and the order in which we multiply the trigonometry ratios like cos theta, sin theta, tan theta, sec theta, cosec theta, cot theta, sometimes the cos theta into sec theta of the multiple orientations, and there are different kinds of orientations. For every triangle constructions, there are four kinds of symmetries, and for every kind of symmetries, there are 6 or 8 kinds of orientations to construct. Here you can see the orientation of the triangles are constructed such that the nearest sides can come together and they can get aligned and glued. That glued means the welded, and in this way the space frames are constructed. The space frames, the whole space frames or the 2D frames, whatever we can think, are nothing but mathematically formalized as the multiplication of numbers. These numbers are the ratios or the rational numbers or sometimes the irrational numbers, and which are multiplied one after another with the certain orientations and certain symmetries. These are constructing the meaningful trigonometric expressions, and these are the GT simplexes. In 3D, when we place the different orientations of similar triangles or dissimilar triangles with particular numbers, then we can see that these are the GT simplexes and they can represent this kind of 3D frames, and which are visible to you in front of your eyes, and which are constructed as the metro stations or the stadiums or any facade. We can design it in that way. You can see the orientation of the line segments which are constructed one after another, and in that way the space frames are created, and all the whole space frames are represented as the multiplication of the numbers. Suppose in the infinite series you can see 1/3 into 2/4 into 4 by 6 into 6 by 8 into this kind of things are visible, and polynomials are also polygons. The GT simplexes which can become 2D frames or 3D frames, and ultimately if we choose the right ratios in the right order, then we can get proper 3D frames, and whole 3D frames are representable as the multiplication of rational numbers or multiplications of irrational numbers. If we change the orientations, or if we change the multiplication order in the non-commutative trigonometry, then the whole structure can change, which can have the same numerical value, but because our numerical mathematics is commutative, but geometrically the mathematics is not commutative. So in geometrifying trigonometry, commutative law don't hold, but associative law holds. These are the GT simplexes, and GT simplexes has a very interesting meaning in 3D geometry, and we are trying to show the triangulation formulation with the multiplication of numbers. These are just the multiplication of numbers interpreted with the geometrifying trigonometry as the space frames. You can see here the space frames are automatically constructed one after another, and the whole BOQ are also created because the multiplicated value is fixed, and we can get the isoperimetric 3D frames and weighted 3D frames. That means the total weight of the whole 3D frame remains same, but the shapes can change drastically. These are the beauty of geometrifying trigonometry, and with the geometrifying trigonometry we can do the finite element analysis with finite element framing, and also we can get the automated free body diagrams in 3D, and such that we can automatically find some minimum energy configurations of multiplication of numbers, with which we can think that the total load distributions are easy when we multiply the numbers in a certain order. These are the theorems of geometrifying trigonometry, where we, with the uh, properties of numbers and properties of multiplicabilities and properties of the divisibilities, we can define the weight of a 3D frame. That is a very interesting part, and where we can connect the whole structural engineering or the DNA structures with pure multiplication of numbers. This is the beauty of Sanjoy Nath geometrifying trigonometry.